All right, welcome back. So we have just a little bit left to say on this section. It's a pretty short section. So I really just wanted to bring this part up, though, because it is going to be a little more to digest, and I want to give you some time to start just thinking about it a little bit. We'll get more into it towards the end of the semester. Hypothesis testing really throws students for a loop. But what we have here is just something to keep in the back of your mind, which is whenever you get a result that is significantly rare, meaning low probability, many standard deviations away from the expectation, chances are good that one of two things happen. Either your data is bad, and if you're sure your data is good, then chances are very high that your assumptions were wrong. So in this case, assuming we had good data here, which I trust thermometers, chances are that either the mean was too high or the standard deviation was too low, or maybe both was wrong. Or maybe that was too high, I forget. But anyway, it actually is the case that 98.6 degrees is, for modern people in 2020, a little high. The mean body temperature for people these days is actually closer to 98.2. Not that that's, terribly important for statistics, but it's interesting. And it does pave the way for a discussion that we will have, which is hypothesis testing. All right, but to round out this section, we'll do one more example real quick. Let's say I got a class of 32 students. Actually, I should probably have about 80 students for the math to work out, but we'll get to that in a second. Suppose I'm breaking them down into 4 people in a group. And also suppose I got a normal distribution on the class grades, which, again, we'll worry about the actual specifics of how that can happen in such a small population. But sure, we have it. And the mean is 75, standard deviation is 10. And I want to know, what's the probability that any group I pick is going to have a mean grade of at least a 70? And I want at least a 70 here because if I get a bunch of smart students here, well, that's fine. But if I get a bunch of students in a group and none of them are doing terribly well, then that group is going to struggle. So what's the probability that if I form random groups, the mean grade of my students will be at least a 70? So let's make sure we can do the central limit theorem and then do it. First of all, we can, right? I did assume the population was normally distributed, so I've got that going for us. The sample size is 4, so really let's just make our adjustments and see what happens. First of all, the desired sample mean is 70. The population parameter, which doubles as the mean of sample means, is 75. The original standard deviation was 10, so I'm going to divide by the square root of my sample size, which is now 10 over root 4, which is just 10 over 2, or 5, and that's our new standard deviation. So I run these numbers and I get a z-score adjusted of -1. I look that up on the z-table and I get the probability of having a z-score less than that to be about 15-16%. 0.1587 was the exact value I got off my z-table. But remember, I'm not done here. I want to know what's the probability of being above that threshold. So I do have to do the complement. I take 1 and subtract away 0.1587, and that gives me an 0.8413, or about an 84.13% chance that each randomly selected group has a mean grade of at least 70. And that's how we can do that. And so that's honestly pretty good. Pretty good. I like those chances. Now, one thing I mentioned here was this size is a little scary small for what we're working with, especially with 4 members in a group. I want you to remember something, and we're going to end with this. I don't think this part's going to show up on your homework, but just in case, and even if it doesn't, it's just good to know. But in general, when we were working with binomial distributions and actually normal distributions, sample sizing, in order for randomness to persist, you don't want to take more than 5% of your full population in a sample. If you take more than that, you start to lose randomness. So if you have more than 5% in your sample, you do have to multiply by something else here. And that's an additional correction factor. But again, not on the homework, just something to think about. All right, take care.